Hello, everybody. I'm super excited to be here. My name is Camila Ramos, and before I start off, I just want to give a huge thank you to Michelle, Gabe, the whole organizing team, the production staff, the AV crew, everyone who helped put this together. Thank you so much. All right, so my name is Camila Ramos. I'm a DevRel engineer at Edge and Node, and I'm here to talk about some things that hopefully you guys will find really cool. So before I get started with my presentation, just a little bit about me and my background. So my calling, I feel, has always been education. I've always loved teaching. I've always felt that it was my path. But when I got old enough to realize that teachers don't really get paid well, I had to figure something else out. And that's when I went into engineering. And after I went kind of the more traditional path, I studied computer science in college. I figured out that I could kind of do both, and I've been teaching kids how to code since 2016. And as you guys heard, in 2018, I founded what's now come to be known as STEM Tank, the nonprofit focused on bringing Black and brown engineers. We've taught over 400 kids in low-income areas in the Bay Area how to code, and it's something that I'm really passionate about. And then when I found out about this thing called DevRel, where it's like, yeah, you can teach adults and do engineering. It was like my dream job. I started off my professional engineering career at PayPal as an intern on the checkout team, and then I returned as a full-time engineer where I worked on the checkout experience for about a year and a half before going over to DevRel. And I'm here to talk to you guys about Graphql and Web3. Now, I know this is a React conference. Raise your hand if you know what Graphql is. Cool, so mostly everybody. Raise your hand if you know what Web3 is. Okay, cool. So my colleague yesterday, Nader, actually gave a really good talk about Web3. So I know if you were here yesterday, you've heard it at least. You kind of have the basic idea, but raise your hand if you're still like mad confused about what that really means. Yeah, cool. So in my talk, I'm hoping to kind of simplify things, bog it down, and really explain kind of the core concepts so that I can get to the GraphQL part and really set the stage so that everyone leaves here understanding how to use GraphQL and Web3. Now, blockchain. Raise your hand if you know what blockchain means. Like, you've heard this before, you kind of know what it means, right? So blockchain is a distributed public ledger and peer-to-peer network. That's kind of my best definition of it. But now as an educator, I really hate when people use other complicated words to define something complicated, so I'm going to break it down a little bit further. So distributed, it's distributed in the sense that it's a database that stores transactions or updates to state across a network of different computers. So it's not just stored by one company, by one person, it's shared across a network of different computers. Now, public ledger is a verifiable transaction history between parties. So you can think of it as like a way to see, hey, who sent this to who, what time did it happen at, who was the sender, who was the receiver. So it's a public ledger in the sense that anyone can check this blockchain, learn about the transaction history, and it's open and accessible to anybody. And finally, a peer-to-peer network, meaning that every participant in the network can send and receive data to and from any other participant without any middleman. So a really good example for me, I'm from Colombia, my family's from Colombia, and to send money, thank you, to send money, it's such a hassle, right? Like, you have to find something that works for both countries, something that's not banned in either country, and then you both have to do all of the work to get your papers in place, your identity verified to be able to send money. And in this case, this peer-to-peer network where there's no intermediary, I can just get on, open my wallet, find the wallet address of where I want to send this to, and it's done. There's no one in the middle. I can directly access any other peer in the network. And then why Web3? So for me, I'm a people person. I don't really particularly care for any technology just for the sake of technology. I'm interested in how it affects people, how we can leverage it to help people, how we can help communities. So for me, kind of what stands out for why I'm here and why I'm doing this are a few things. So this isn't an exhaustive list. This is kind of just what sticks out the most to me. So this idea of agency and owning your own data and owning your own identity, where instead of all of your data and everything associated with the moves that you make online being stored on somebody's server, like on Facebook's or Twitter's, and then they harvest your personal data, they sell it to advertisers, they sell it to marketers so they can sell you stuff, and everyone in this loop is making money except you off of your data, off of the content that you created. The next one is permissionlessness. So the fact that there's no central authority, there's no one in place to say, you can't do this, or you need to check with me before you send money to Colombia. You got to give me your ID. You got to give me your social. I got to get this information before you can make any move. Another one that I really love and I love to explain is reliability. So because the blockchain is maintained by a bunch of regular people like you and me, this distributed network, it's way more likely to run forever than infrastructure run by private companies, right? Because at any time, these companies can be like, oh, we got bought out, or I don't feel like doing this anymore. And they're all in their right to do that. They can do whatever they want with the stuff that they run, with the infrastructure that they support. And with blockchain, it brings us into our next point. There's this built-in incentive, this financial incentive to keep the network secure, to keep the network going. So the stuff that you build on Web3 is much more likely to last than stuff kind of in the traditional space. Now, for those who maybe don't know GraphQL, I'm just going to do a real quick cover. So we use GraphQL to read data from some database, or we might even use it to call another API. And you make a request via a query. You send this to your API, reads from some database. It applies some logic to construct this object that matches your schema and then returns it to you. Now, same exact thing in Web3, except instead of reading from some private database, you're reading directly from the blockchain. And this idea of resolvers is still there, where you're writing resolvers to construct and return an object defined in your schema. So for people who, I know there's some students here who got some tickets. I'm so happy you guys are here. Side note, I remember being a student and going to a JS conference and having no idea what they were talking about, because everyone was just talking at this super high level. So I wanted to make sure that even the students in the room could understand. So an example of what I mean when I say resolvers is let's say you're reading from a database, I don't know, a bunch of scores from a test, and you want to say, give me the average score of the test. Now, you normally wouldn't really do this, but let's just use it as an example. The resolver would say, all right, let's grab all of the scores, find the average there, and then return that to the client. Now, when we think about a blockchain, right, how many blocks, okay, so sorry, let me take a step back. A blockchain, one thing that I actually forgot to mention is that kind of what makes up a blockchain, why is it called block and then chain, right? So transactions are stored in batches known as blocks, and then all of these blocks are linked together, hence blockchain, right? So I want people to take a guess at how many blocks are in the Ethereum blockchain. And I actually want you to say it out loud.
420.
Nope. More. Another guess. How much? No. More. Say it. No. Less.
10 billion.
Less. Did you say 10 billion? Okay, less. But almost. The number at the time of me writing this presentation, which was about a week ago, was 14,525,770. So this is just to give you an idea of how many blocks, and that's just the blocks, right? The actual number of transactions is way bigger than this because all these transactions are batched together in a block. And now you, as a developer who might want to query for some of this data and maybe serve it up in your client, your data's in here somewhere in these 15 million blocks. And now the problem is that due to the nature and the structure of a blockchain, the data that you might want to query for could live at different blocks, and there's no built-in mechanism to identify, categorize, or query for that data. That's where the graph comes in. So the graph is an indexing and query protocol used to efficiently read data from the blockchain and expose that via a GraphQL query API. And kind of also looking back to the students, when I say protocol, it's just a set of defined rules to meet some outcomes. So for example, in the grocery store, the protocol for checking out is you stand in line. When you get to the front, you put all your groceries on the belt. When all your groceries are scanned, you pay. So it's just a set of rules to kind of get to this goal of efficiently reading from the blockchain. Now, the point to really take in and understand here is efficiently, because you can read data from the blockchain without the graph. There's public methods that expose some data that anybody can read and anybody can access, but you're only going to be able to read like one piece of data at a time. And also, a side note, indexing refers to a process of turning unordered data into an order that will maximize efficiency made against that data. So if I gave you a list of names and I asked you, hey, find how many names in this list start with a C, you could go through every name in the list one by one, check, does it start with a C, until you get to the end of the list. But if you wanted to do something like indexing to maximize the efficiency of this query, you would maybe put it in alphabetical order. And then, the first name that doesn't start with a C, you would stop there instead of searching through the whole list. So that's what the graph does. We index all this data, we put it in a way that makes it really efficient and fast for you to read from the blockchain. Now, to really kind of illustrate the problem that we solve, I first want to start with what this would look like without the graph. So let's say that you wanted to build an API for somebody to search an NFT that matches certain traits, right? Like right now, kind of a lot of people are using NFTs as profile pictures. And let's say for me, like I want to have one that at least resembles me, so when people see me, they can like maybe make out that it's me. So what you would do if you didn't have the graph, actually I'll show you guys this in a second. But if you didn't have the graph, you would have to take each token ID, which maps to one token, or in this case, they're called ladies or women, that maps back to one woman. You would read all the metadata. You'd have to manually aggregate this together. Maybe on your client side, you would write a program to filter this based on whatever input you get. The other scenario would be that you can run your own server, you can process and store all the transactions made to the blockchain, save this into a database, index it, and then build, maybe a more traditional like API on top of this. Problem is that both of these routes take way more engineering power and time than any single engineer will even want to do, even if they had the resources and times to do, and it takes entire engineering teams to do these processes. Now, with the graph, it allows you to do much more sophisticated queries and do things like filtering, mapping relationships between full text search, and pretty much any query that's more than one piece of data at a time. Because like I said, right, you can grab one piece of data, you can say, hey, who's the owner of this specific token? You can say, what's the balance of this wallet address? And you have to do these one at a time. If you wanted to do something like aggregate data, you would have to do it one at a time until you get it all together. So the graph helps you out with this. And the way you would do this is you define what's called a subgraph. And anybody can make one, any developer can make one. Once you publish one, if they're open, available, anyone can use your API. Now, I love this illustration because I'm a visual learner. So the subgraph is kind of the layer that sits between your smart contract or the blockchain that you're indexing data from and your UI, just like it does in Web2, right? Now, developing a subgraph is super easy, and I'm going to show you guys that today, but the things that you have to define as a developer are the data source, so the contract that you're interested in learning about, the data that should be indexed. So you're going to say, for example, for our scenario, I want to be able to index the hair color, the skin color, the face expression, and maybe the eye color, right? If I want to find something that looks like me. The events that you want to listen for, this is kind of getting like a little bit more into the weeds for someone who might not be super familiar with Web3, but to simplify it, the blockchain stores states, right? And every time you make a transaction, you update the state of the blockchain, and that's broadcasted throughout the network. So if you have some data from, a state change, let's say 5 days ago, and you query it today, without updating that, you're going to get stale data. So in order to get the freshest data all the time, you got to say, I'm going to listen for these events, and when these events happen, I want you to find the newest data. So we define what those events are, and in our case, the event that we're going to want to listen to is called transfer, because that's the event that gets emitted in a smart contract, specifically for NFTs, when it gets transferred from one person to the other or when it gets minted for the first time. So basically, like as soon as this gets on the market and it's available as something to be bought, I want to index the data. Also, if it ever changes owners, I want to know that too, because if I want to buy an NFT, I kind of want to know who the owner is so I can go approach them and give them an offer, right? And then finally, the resolvers to be executed when these events are emitted. And you only have to edit 3 files. It's really easy to get started. So the first file is the manifest. You just define the start block. And by start block, I mean you could start indexing from the very first block of Ethereum, the Genesis block. But if you know, for example, my contract was deployed 6 months ago, it's definitely not in the first block. It's definitely not in the first 13 million blocks. So you can define that block so you kind of don't have to waste that time indexing from the very beginning. You define the entity names, and by entity I mean what are the objects in your schema. You define the events and the event handler. So what we just talked about, all of this goes in the manifest. Schema, same as GraphQL, you define objects. The only thing that you'll see here that's different is the entity directive, which you see next to lady, and the derive from directive at the bottom by user. An entity is just what we use to say, hey, this is an entity, this is an object in our schema that's unique to the graph. And also the derive from allows us to describe relationships between. So remember I said the graph is good for mapping relationships between. So if I want to know, give me the wallet address of this particular token, or let me see all of the tokens that this wallet address holds, that's a directive that we use to build that relationship. And then finally, you write your resolvers. An assembly script, so if you're a JavaScript developer, if you've written TypeScript, you're writing an assembly script here, but it's pretty close. And there are some weird things about assembly script. And I actually have this whole set of resources for JavaScript developers getting started with assembly script, which I'll talk about a bit later. Now, I'm going to show you guys how fast we can do this. Cool. So I actually have a workshop available to do just this. So I'm not going to go super in depth right now because of time, but I'm going to have a QR code to this at the end, so don't worry about pulling your phones out or trying to squint. I'll have all these resources at the very end so you can see that. So you guys can see, cool. So the first thing that we're going to do is we're going to head over to the graph. We're going to go to the hosted service. And so we have the hosted service, and then we have the decentralized network. The reason why I'm using the hosted service right now is because I'm going to use an API that isn't available yet on the decentralized network. It hasn't reached feature parity, so just for now, we're going to use this. Head to your dashboard, create a subgraph. I'm going to call this Miami subgraph. Oh, this has to be uppercase. Cool. So now that the subgraph is created, I already have the CLI installed, but you would have to install your CLI. And then I'm just going to run the command directly from my workshop so that I don't have to switch back and forth. And so here we go. So this is the command that you do to initialize your subgraph. Can you guys see that? Is that good? All right, cool. Maybe it's too good, actually. There you go. Okay, it kind of wraps ugly, but here, maybe I should use this laser. Does this work? Okay. So we're initializing and we're passing in the contract address, which you can find by going on Etherscan. This is all in the workshop, so if you don't really know what that means, just a website, you can find any contract address there. So I'm passing in the address. I'm saying this is the data source that I'm interested in. I'm passing the contract name and this flag index events that will kind of give us some helper code to get started, and it'll automatically index the events in this contract for us. Pick Ethereum, hosted. For name, you have to put your GitHub, and then the name of this, what did I say, Miami subgraph. Did I say subgraph? Yeah. Miami subgraph. Cool, so now once this is done, we're gonna open up this in our code editor, and you're gonna define your schema. So same as Web 2, I'm just gonna copy and paste everything, but the two objects that we're gonna define are the lady, because this is a collection called crypto ladies or something like that, and we're gonna define the object user, because I wanna be able to find this relationship between the token that I want and who owns it. So once this finishes up, I'll do that. But while this is loading, I'm super happy to be here. This is my first talk ever. Cool, so now that we're in here, I'm just gonna open this up. VS Code, I'll let this take over this space here. In my schema, I'm just gonna paste this over, but here we're just defining all of the properties that we wanna be able to query. And one thing that I actually really struggled with when I was first getting started with the graph is I was like, how do you know what properties are available? Like, what if I want to query for attitude? Like, is there an attitude property? How do you know what properties are out there? So the way that you do that is actually you go to their contract in Etherscan. You go down here to contract. Can you guys see well? Should I zoom in? You go down here to contract, and you go to read contract. And if you go to this base URI, so this is what I meant when I said you can query for things one at a time. So actually here I can query for all these things, but only one thing at a time. So I'm going to take this IPFS hash, which is where the metadata is stored. I'm going to go to ipfs.io/ipfs/this/a token ID. I'll just use 20. Oops, what did I do? IPFS. There we go. And here I can read the metadata. And actually, I'm just going to pop this into a JSON formatter so we can read this a little bit better. Oops. Cool. And then this is actually what informs you on what you can actually query. So if we look at this, this is just an object. Inside the object, we have an attributes array, an array of objects, where each object is a different attribute. And the key value pairs here are the name of the attribute and then the value. So this is what informs you on what is actually available to be queried. So I know I can only query what's right here. If I wanted to query like for attitude, you can't do that because it's not a value that is associated with this token. So I went here, and now I'm going to paste in the user one, save that. Then I'm going to head back to my terminal and run this command, graph codegen. And this is going to get some code for us out of the box. Cool. And now we can head over to our subgraph .yaml file, which is the manifest. And the only thing that we're going to update here is, so I passed that index events flag, so it got all the events for us. But the only event that I'm interested in is the transfer event. I only care when it gets minted and then when it gets passed to the hands of another owner. So I'm deleting everything else. And then here I'm going to add the start block because I just don't want it to index from the very beginning. The start block is 1281301. Cool. And then we save that. And then finally, the last thing we got to do is go to our assembly script mappings. And if you see here, it has these other types that were originally, that came kind of when we started this boilerplate, but we're not using these. We're using lady, and we're using user. And then also don't need these because I'm just interested in the transfer and the handle transfer. Boom. So also I'm going to copy this because it's going to take way too long to write right here, but I'm going to talk through it with everybody. Also the code, everything is here, so don't worry about trying to take pictures or anything right now. So here we go. I'm just going to copy all this, actually. Cool, and I'm going to include some libraries that are going to help us do this fun stuff. I'm just going to copy this line up here. All right. Cool. So now let's make this big screen and kind of talk through what's going on here. Is that good? All right, cool. So I'm passing this IPFS hash because, as we saw, we need that hash to actually access the metadata. It's not stored on the blockchain. A reference to this hash is stored on the blockchain, and then the metadata is stored on IPFS. So I'm letting it know, hey, this is where you can access the metadata. I'm saying if there is no lady, let's create a new lady object. Let's set the token ID value. Let's set the token URI. And then here's the part that it kind of gets interesting. So when we get to metadata, we're saying, all right, this is how you access the metadata, this IPFS.cat. Method, you're going to take the IPFS hash, which is the constant that we provided above, and then the token URI, which is the token identifier for that specific token. And we say if there is metadata, if this comes back as something, if we're able to successfully find something, we're going to take this. Remember, we saw it was a big object, and then inside there was an array of objects. So we're going to take the big outer object, and we're going to define the name, because in our schema, we asked for the name. And if we actually pop back over here, the name is not inside of the attributes array. So let's go here. So we see here, the name is up here. So it's in the outer object. So we haven't done anything except go one level in, get the name property. And if you notice, all the attributes are one level deeper in an array, right? So we're like, cool, get us the name. Now we're moving on to the attributes. So it's an array. And we're going to find the value called attributes, remember, because that was a key, and then the value is an array. So find the key called attributes, and then when you get there, you're going to loop through these attributes and then find them by name. So if I kind of skipped over some stuff, but really what it's saying here is loop through all these attributes, identify the values, identify the names of the attributes, and then we're going to go through each trait, and then we're going to check if this trait equals something that I'm interested in, like for us it's hair, skin, eyes, face expression, then we're going to save that value to our object. So this is the part of our resolver where we're constructing our objects, and then we're returning it back. So this part is the construction part. We're saving all this, and then kind of the most important thing here is this .save method. This is what actually saves our object to the graph node and makes it available for you to query. And then we did the same thing down here with our user. So we're just going to save this. I'm going to head back into my browser and find this command to deploy it, and then we're done. What's my time? Oops. I have 10 seconds left. Actually, I'm not going to deploy it because it's not that important, but it's just one command to deploy it, and then you're done. Where are my slides? So wrapping up here, I really hope that was... Okay. Cool. me just go back. Cool. So now that we're here, there we go. Okay, now start building. Now you know all about the graph. You know how to build stuff. So much money in the ecosystem to get started. I got started through the grants programs. It's actually a really good story. I got started through the Graphs grants program. I started off as a grantee. You don't have to be this super crazy, huge engineer to do it. Use your gift. My gift is teaching. My gift is education. My gift is making things easy to understand. So I got a grant for making TikToks about the graph that eventually turned into a full-time job, and now I'm here. This talk was actually submitted months ago before I even started working at Edge and Node. Another resource to start building, 30 Days of Web3. Women Build Web3 is starting a 30 Days of Web3 initiative in about 2.5 weeks, where we're going to provide a content map and guide and get you to ship a Web3 project at the very end. Would love to invite you guys all to Graph Day, happening in San Francisco next month, where you can come learn about a bunch of cool Web3, hear about Web3 founders, CEOs, kind of about the future of what they think is the future of Web3. Finally, here are the resources for you to take a picture of if anybody's interested. And before I actually go to commemorate my first talk, I want to take a selfie with everyone. So you guys say cheese. Ready? 1, 2, 3. Ah! Okay, cool. Thanks so much.